Okay, here's example 2 with graphing trig functions with simple transformations. So here what we're going to do is graph y equals sine of x and y equals sine of the quantity x minus pi over 2 together on the same set of axes here. So here's our long x-axis, and then here's our y-axis. So remember, we're just doing basic pre-calculus type transformations here. So remember, if we have sine of x and then we do sine of x minus pi over 2 like this, how does the graph of this guy relate to the graph of this guy? Well, remember, inside like this, so let's think of it just more generally. So if you have the graph of y equals f of x, if you want to shift that to the right by, let's say, 3 units, then what you do is graph y equals f of x minus 3. Okay, so remember, it's kind of backwards with the minus sign. So even though it's x minus 3, it's shifted to the right 3 units. Okay, so that's what's happening here. So in this specific case, we have sine of x, but then here we're going to graph sine of x minus pi over 2 also. So this minus pi over 2 is going to take the graph of sine of x and push it to the right pi over 2 units. Okay. So this is actually an example of what's called a phase shift. So phase shift, so let me write that over here. So even though it's just a horizontal shift, actually phase shift is just a fancy term that means horizontal shift, sort of. So for trig functions, horizontal shifting, this phase shift here, that's all that means, horizontal shift. This phase shift is sort of a special thing, and it kind of complicates things a little more than it does for other types of functions that you talk about in pre-calculus. So it is a special topic that will be talked about again later. But for simple ones like this, we can still treat it like we do in pre-calculus, just with other different types of functions. So here we'll just treat it as a regular horizontal shift to the right. Okay, so remember, if we have f of x, then f of x minus 3 is a horizontal shift to the right. So here's sine of x. Sine of x minus pi over 2 is a horizontal shift to the right pi over 2 units. Okay. So first what we want to do is just start graphing sine of x. So first let's set up some scales here. So let's make positive 1 up here, and negative 1 will be down here. Okay. So let's put pi over 2 over here. So this is pi over 2. This will be pi. This will be 3 pi over 2. This here will be 2 pi. Oh, and just like in example 1, if you want to follow along with some graph paper but you don't have any, check the video description here. There will be a link. You can click on the link, open up some graph paper, and print it out. So 3 pi over 2, 2 pi, the next one's going to be 5 pi over 2. And then 3 pi. Okay, so we probably don't have to go much farther than that. We'll worry about it later if we have to. Now if we go this way, so keep the scale the same going to the left, so negative pi over 2, and then negative pi, negative 3 pi over 2, and then negative 2 pi. Okay. Alright, so let's go ahead and graph the sine function first. We want to graph these on the same set of axes to see how they relate to each other. So here's the sine function. We know it goes through 0, 0, pi over 2, comma 1, so let's come up like this. So we gotta have that kind of curvy sine type shape to it. Then we come back down to pi, comma 0, down to 3 pi over 2, comma negative 1. Then we come back up to 2 pi, comma 0. Okay, so that's one full period, 0 to 2 pi, so everything's just gonna repeat after that. So we can repeat, go up to 5 pi over 2, comma 1, come back down to 3 pi, comma 0. And then we can continue out this way. So I actually didn't really want to go that far here, but too late now. Anyway, if we go back out this way, we're going to go to negative pi over 2, comma negative 1. We'll come back up to negative pi, comma 0. So kind of make it a smooth, rounded corner there. Then come up to negative 3 pi over 2, comma positive 1. Back down here to negative 2 pi, comma 0. Okay. Okay, so that wasn't too bad, I guess. So anyway, that's the graph of y equals sine of x. Okay, but now what we want to do is take this, so now we want to graph y equals sine of x minus pi over 2 like that. So all that's going to do is take everything shifted to the right by pi over 2 units, okay? So I don't really have another color here I could use. But anyway, just take this, shifted to the right pi over 2 units. Take this guy, shifted to the right pi over 2 units. Take this guy, shift him to the right pi over 2 units. Same thing here, take this guy, shifted to the right pi over 2 units. And that just keeps going on for each point here, right? So start over here, go up like this. So it's going to have that exact same shape, just pushed to the right pi over 2 units. Okay? So now it's getting a little cluttered up here. Anyway, that's what's going on here. Okay, so let's label this next one then. So 5 pi over 2, 3 pi, 7 pi over 2 is next. 7 pi over 2. Okay, and then we come down here like this. Okay. So that's that there. Now let's go out to the left. So, but still, same exact thing. So everything's just getting shifted to the right pi over 2 units. So this point moves over to this point. This point moves over to this point. This point moves over to this point, like here. Okay, so we'll just connect them like so. So again, same exact shape, just push to the right pi over 2 units. Okay. And again, this is a simple example of what's called a phase shift. So this point moves over here. And phase shift can make things a little more complicated. So for this example, so here y equals sine of x minus pi over 2. Okay, sine of x minus pi over 2 like this. So for this example, there's not much, or there's nothing else happening, so the phase shift really isn't that bad. But when you start combining everything together, that's when phase shift makes things kind of tricky. So when we do more complicated examples, we'll save the phase shift for the end. But anyway, let's see how the domain and range were affected. So what's the domain and range for the new function that we just graphed, for this sine of x minus pi over 2? So first of all, did that change the domain at all? What's the domain of the sine function? It's all real numbers, right? Negative infinity to positive infinity. If you take the graph shifted to the right, that doesn't change the domain at all, right? You can still take any value of x you want and toss it in here, okay, and you'll get a value of y back. Now, because you shifted to the right, you'll get a different y value back than you would if you just put the x into here, but it doesn't matter. Okay, the point is you can take any x you want and stick it into here. Okay, so the domain is still all real numbers. Okay, how about the range? Well, did we change anything vertically? No. So remember the range, that's the set of all the y values, so negative 1 to 1 for the sine function. But all we did was shift horizontally, so we moved to the right pi over 2 units. And if you move only to the right, you do not affect the y values at all. You do affect the corresponding x values, but that doesn't matter. The point is you still have the same set of output values. They do correspond to different inputs, but it's still the same set of output values. So the range is still negative 1 to 1. Okay, so horizontal shifting does not affect the range. So if we shift only to the right or only to the left, the range stays exactly the same, because the range corresponds to the y-coordinates, which is more of a vertical thing. But since we only change things horizontally, the range stayed the same. So anyway, domain and range are the same for this guy as they are for this guy. Okay? And that's example 2 with simple types of transformations for trig functions. And again, this is a special type of thing called a phase shift, which does make things more complicated, but in this case, not so much, because that's the only thing that's happening. But when we combine it with everything, then it gets a little more complicated, which we'll see a little bit later on. So anyway, that's example 2.